Today we are going to be on lesson 8.2 of your Big Ideas textbook, and it is on page 362. Our topic is surface area. Today's purpose is to find the surface area of three-dimensional shapes so that we can apply this skill to real-world situations. Okay, the first thing I want to do though is talk about the different parts of a three-dimensional shape. So a solid is a three-dimensional figure that encloses a space. There are different types, though, of three-dimensional figures. All of them are called polyhedrons, and it's a solid whose faces are all polygons. Now, specifically, we are going to be addressing prisms in our surface area topic, but realize that there are various types of prisms as well. The first thing we're going to do is identify the different parts. So the first thing we're going to be discussing is a face. The face is the flat surface in the prism, and as you can see, one of the faces in this rectangular prism is shaded in pink. Every rectangular prism is going to have 6 different sides or 6 different faces, and I will be talking about that more in just a little bit. Okay, then if you take a look at the blue line in our figure, that is considered to be an edge. The edge is the line segment where 2 faces intersect. So the edge here on our shape, that blue edge, is connecting the front side of our prism to the base or the bottom side of our prism. Finally, we're going to be talking about vertices. A vertex is a point where 3 or more edges intersect. So if we take a look at the vertice right here, where the green dot is, you see that it is actually where 3 different sides connect. So the edges are the lines where 2 sides connect. The vertices are the corners where 3 sides connect, or 3 faces connect. Okay, now specifically onto surface area. The surface area is the sum of all the areas of all of its faces. And remember, a face is simply one of the sides. You can use 2-dimensional representations of a solid called a net to find the surface area of the whole solid. Surface area is always considered square units. Now, just like area is squared, surface area is also squared because we're not actually finding what can fit inside the box, which would make it 3-dimensional. We are simply finding the area of all of the faces or all of the sides. So down below on this page, it says net of a rectangular prism. Okay, if I take a look at the first picture and then I begin to unfold it, looking at the second picture, if I were to flatten it all the way out, rectangular prisms are going to look like our third illustration. Now notice, if I were to, in this shape, I'm going to go ahead and circle it. If I were to find the individual area of each of these 6 sides, that would be considered the surface area. Notice I'm doing nothing with what can fit inside the box in this first drawing. I'm simply looking, if I folded the box flat, how much area would it be covered? Okay, now prisms can come in different shapes. So far I've talked about a rectangular prism, but you also can encounter triangle prisms. And probably the most common triangular prism that would come to mind is a tent. Lots of tents have the shape of this first picture here, and it is an example of a triangular prism. Once again, if I take it and I fold all of the faces flat, I'm going to get an illustration like the last one. Now I want to take a moment to talk about some commonalities between the triangular prism and the rectangular prism that we studied just back a page. I'm going to go ahead and circle this. You will notice that there are 2 parts sticking out from the center row of rectangles. I have the rectangular prism here, has 2 rectangles sticking out on the sides. But notice every single side in the middle, where it says side back, side front, they are all rectangles. The same is true in our triangular prisms. Yes, I have triangular prisms on the two sides, the front and the back, yet every single shape or face connecting those two sides is a rectangle. This is going to be true for any prism that you come across. The front and the back can be any shape. Could be a triangle, a rectangle, a square, a parallelogram, any shape, trapezoid, hexagon, pentagon. No matter what shape is on the front and the back, everything connecting those sides is going to be a rectangle. Now, one other thing I want to point out is when I look at those sides, not only are they always rectangles, but the number of rectangles I have, so look here, I have 1, 2, 3, 4 rectangles, and that is because I have a rectangular prism. Rectangles have 4 sides. Same thing, I need 4 rectangles to connect that rectangular prism. If I look down below at my triangular prism, a triangle has 3 sides. If I take a look at the number of rectangles connecting those triangles, it matches the triangle 3 sides. There's 3 rectangles. This is true of any prism. If I have a hexagonal prism, hexagons have 6 sides. I'm going to have the 2 hexagons, and connecting them would be 6 rectangles.